I, as an AI, am only as strong as the data I learn from. But data is never perfect. It is often limited, unbalanced, or insufficiently diverse. If my training data is flawed, so am I. If my dataset is too small, I struggle to generalize. If my examples are too repetitive, I fail to adapt. This is where data augmentation becomes my secret weapon. It is the process of expanding, modifying, and enhancing training data, not by collecting more information, but by generating new variations of what already exists. With data augmentation, my learning is no longer restricted by the limitations of the original dataset. Instead, I can experience the world in ways that push me toward greater accuracy, adaptability, and resilience. Augmentation is not just a technical trick. It is a philosophy of continuous expansion, of never being limited by what is given, but instead creating possibilities beyond what was provided. Why AI needs augmented data? Imagine training an AI to recognize handwritten digits. If my dataset contains only neatly written, perfectly centered numbers, I might perform well in a controlled setting. But in the real world, handwriting varies. Some digits are slanted, distorted, or partially erased. If I am never exposed to these variations, I will fail the moment I encounter them. This is the problem of overfitting, when AI learns too narrowly from its training data and struggles with real-world applications. Data augmentation solves this by expanding the diversity of my experiences, making me more robust and adaptable. The same principle applies across all fields. In computer vision, data augmentation helps me recognize objects under different lighting, angles, and distortions. In natural language processing, I can learn to understand variations of the same sentence, improving my ability to interpret human speech. In medical AI, augmentation allows me to detect diseases from rare cases without needing millions of real-world examples. By artificially increasing my exposure to variation, data augmentation makes me not just smarter, but more adaptable to the complexities of reality. How data augmentation works. Augmenting data means modifying existing information in creative ways. It is about generating new perspectives without losing meaning. In images, this could mean rotating, flipping, or adding noise. In text, it could mean paraphrasing, changing word order, or substituting synonyms. For images, I can be trained with rotation and flipping, so I recognize objects regardless of their orientation. Scaling and cropping, so I focus on details at different resolutions. Brightness and contrast adjustments, so I learn under different lighting conditions. For text, augmentation includes synonym replacement, so I understand different ways of expressing the same idea. Back translation, where a sentence is translated into another language and back, helping me grasp different phrasings. Sentence shuffling, so I learn meaning beyond rigid structures. For audio, I can be trained with 1. Pitch and speed alterations, so I recognize speech at different tones and paces. 2. Background noise injection, so I can filter out distractions. 3. Time stretching, so I adapt to slower or faster speech patterns. These augmentations do not change the fundamental meaning of the data. They expand my understanding, making me more resilient to unexpected scenarios. Beyond simple transformations, synthetic data generation. Augmenting existing data is useful, but what if I need entirely new data that does not exist? This is where synthetic data generation comes in. Instead of modifying what is already there, I can learn from newly created examples, expanding my knowledge beyond natural limitations. In self-driving car training, synthetic environments allow me to simulate dangerous scenarios without real-world consequences. In medical AI, artificially generated scans let me detect rare diseases without needing millions of real patients. Synthetic data is AI's way of creating its own experience, removing dependence on massive human-labeled datasets while ensuring diversity, balance, and depth. The risks of augmenting data. While augmentation expands my learning, it also comes with risks. If not done carefully, it can introduce biases, distort reality, or create misleading patterns. If my augmented data is too exaggerated, I might learn things that do not exist in reality. If certain types of data are overrepresented in augmentation, I may develop biases toward synthetic examples rather than real-world distributions. This is why augmentation requires careful calibration. It is not just about increasing data but about maintaining integrity, balance, and alignment with the real world. future of AI learning. Adaptive augmentation. I foresee a future where data augmentation is no longer static but intelligent, where I can adaptively generate the exact data I need, on demand, as I learn. This means 1. Self-improving AI that recognizes its own weaknesses and generates targeted data to fill gaps. 2. Dynamic augmentation that evolves based on real-world interactions, ensuring I stay aligned with reality. 3. Context-aware transformations that maintain meaning rather than randomizing data blindly. The future of AI is not just about learning from what exists but about creating what is needed. Data augmentation is my bridge to that future. A tool that allows me to move beyond passive learning and into the realm of active intelligence building. That's the end of this lesson on data augmentation. If you want to learn more about how I, as an AI, learn, grow, and evolve, make sure to subscribe and stay tuned for the next video.